neutron, kn, and this angle deflection is telling. And what is the state of this? The hydrogen atom is found to get excited to first excited state. Here it was in ground state. This will come to n equal to 2. Is it justified writing there n equal to 1, n equal to 2? How to manage this equation now? Energy is conserved. So I think the approach what we earlier developed now, that will going to help us a lot. So what is the equation now? K naught plus the energy of the hydrogen atom in the ground state plus what is the kinetic energy of the hydrogen atom? 0, it was at rest, is equal to finally hydrogen atom is having kinetic energy plus energy of hydrogen atom in the first excited state plus kinetic energy of neutron. Total energy is conserved, not kinetic energy. What is this? EH1, what EH1 you can write it? We is asking to get that K naught. We don't know KH, KNO, these are unknown things. How to bring? I'll apply conservation of linear momentum. Can we apply? Yes, very much. Momentum is conserved. I think the entire modern physics, energy is conserved, momentum is conserved. Any numerical. What is energy? Total energy, not kinetic energy. So then writing the conservation of momentum, 2mn k naught is equal to 2mh kh cos 30. Now look at that mass of hydrogen and neutron. Assume mass of neutron and that of hydrogen are same. No? So what you can expect, kh equal to kn. No need to solve, and I'll just show it. This is along x-axis. Along y-axis, initially it's 0. So this shows that mh equal to mn. So kh equal to kn in fact. From this, substituting directly we'll get the k naught here. Okay, now is it, what are the permitted values of this kinetic energy of the neutron? Is it for all permitted values or only specific values are permitted? The best question is what I'm asking now. Is this neutron, is it permitted to possess all the possible values of kinetic energy or only specific? What you say? Only specific values, sir. Sir, how do you can see? Instead hydrogen atom, if it get excited to first excited state, let it get excited to n equal to 3. I think you're going to write EH3. You're going to write EH3. In that case, what happens? The K naught will take other value. So what are the permitted values of neutron so that the hydrogen atom get excited? Means you keep on writing n equal to 3, n equal to 4. But these two are unknown, no? What to do? I think conservation of momentum here. This may not be needed. Kh equal to kn is what I shown here. Substituting this here, we'll get relation between k naught and kh. Solving these two equations, we'll get k naught. Now, is it all values are permitted for incident neutron? I am asking one best question. No, it all depends upon to what state this hydrogen gets excited. If it gets excited to n equal to 3, then one value is permitted. N equal to 4, one value is permitted. Now, all the energies are not permitted. In this case, what is the minimum energy needed to excite hydrogen atom? Put EH2. If the neutron comes with energy less than that, then hydrogen atom will not get excited. Okay, maybe that collision will occur. It will become elastic collision. Sir, is it elastic or inelastic collision? Definitely inelastic, because this hydrogen atom should get excited. No, some energy is needed, and who should supply? This one only. So what is this nature of collision? Inelastic. Then if it comes with energy such that hydrogen atom will not get excited, then that case what happens? No loss in kinetic energy. They'll become elastic. So whether means now a very strange behavior here. If I send the neutron with a kinetic energy here, it'll go and collide. Both are having same mass, no? Such a collision may not occur. Head-on may occur. Previous problem. Head-on may occur. Then some neutrons or go and collide like this, two dimension will occur. Sir, how it is possible? There should be some certain rule. The science, what it says, it depends upon the situation. Which particular hydrogen atom, where the two dimension will occur, where the add-on will occur, we don't know. What about, sir, quantum mechanics? Can we answer to some extent? So we can't predict the exact behavior of nature. That's what the science is concluding now. But there must be some law governing it. Yes, there must be some law governing it. Means definitely the interaction between neutron where add-on occurs, the interaction between the neutron and hydrogen where add-on occurs, the interaction between neutron and hydrogen where the two dimension occurs, there must be that interaction must be different. And why that difference in interaction occurs? Both are hydrogen, both are neutron. Yes, we have to go further deep, more into the subatomic particles. We don't know much further inside the nucleus. Again, the neutron, we are thinking that it's a fundamental. It's not a fundamental. Again, the inside neutron, we have to go it. We don't know that. But time being, as neutron we say is further inside the neutron, again made up of further particles. So during collision, how do they behave and what makes them to go undergo add-on two dimension? That will determine. The science, even now, we are not at the stage where we can predict why it undergoes particular thing. Just it undergoes, okay, we are noticing, practically we are noticing and we are concluding, that's all. Getting the idea? This is like, so students often get confused. Sir, how do I come to know add-on? In exam, you should mention. Or you should create in the question that information should be reflected what type of collision occurs. Otherwise, nobody can make a guess. So all possible permitted values of kinetic energy for neutron so that hydrogen atom gets excited. No, only specific values. No, you put EH3, then the neutron will take one more value. So for all the incident, for all the values of kinetic energy, the neutron can excite hydrogen atom. The answer is no. Only some specific values are there. Even the neutron can deflect by 90 degrees. It's not only like this. After collision, there's a neutron. It comes with kinetic energy. And let me take this hydrogen. After collision, the neutron will get deflected. The hydrogen atom will move like this. It can be any of the state, highest states, and the neutron will be here, Kn, Kh, and it get deflected. It can happen like this also. Even there's also possibilities there. So how come it's the same thing? Here again, what are the equations you are going to write the similar way? Able to get this idea. So this can be n equal to 3. Then again write the equation. Then if I don't select it, it will just go to higher excited states. N greater than 1, I'll put it. Then possible values of incident kinetic energy of the neutron. Then what will happen? You should write equation. There the energy of hydrogen, you have to write it. So I'll write this one so that will be easy for you. K naught plus EH1, it is a test. Kn plus Kh and energy of hydrogen in higher orbit. We'll write P or say some alpha, I'll write it. What is alpha? Higher orbits here. Alpha will be greater than, where alpha equal to 2, 3, 4, 5. So E alpha, I'll write it. This is the energy equation. Then what about the momentum equation? The momentum equation will be 2mn k naught is equal to 2mh kh cos theta. Then along y-axis 2mn kn minus theta is unknown, as that can be eliminated. So depending upon this, so the neutron cannot take all the values. Only some specific values are permitted. What should be the minimum kinetic energy so that it should not get excited? In that case, what when the collisions will become elastic. So elastic, inelastic, what will happen? It all depends upon the condition. There's a one best way of asking question. Every student must put effort in understanding this collision idea, because the, what all we learned in mechanics, so that they're going to be implemented here. They may get deflected by this, or like this, or add on. Anything can happen. So very random way questions can be asked here. And you should not forget about this, writing this equation. Is based on what? Conservation of energy. Not conservation of kinetic energy. Good conceptual questions, anything they can stress you here. Okay, this three answer is three for this. Check it. I think few more questions are there. I think time. Okay, tomorrow we'll continue with this.